Find emitter current, emitter voltage, base voltage, collector voltage, overall voltage gain, and assuming that emitter current is same value with collector current. We're going to solve for Thevenin's resistance and Thevenin's voltage. So RTH equals to R1 times R2 over R1 plus R2. 47k ohm times 10k ohm over 47k ohm plus 10k ohm. The value for RTH is 8.25k ohm. For VTH, we have R2 over R1 plus R2 times VCC. 10k ohms over 47k ohms plus 10k ohms times the value for VCC, which is 10 volts. So VTH is equals to 1.75 volts. After getting the value for the Thevenin's voltage and Thevenin's resistance, we can now solve the value for emitter current, which is VTH minus VBE over RE plus RTH over beta. 1.75 volts minus 0.7 volts over 940 ohms plus 55 ohms. The value for IE is 1.06 milliamps. We're going to assume that the value of IC and IE is same. So the value for IC is 1.06 MA, which is the value of IE. Since we already have the value for IE, we can now solve for VE, or emitter voltage. So IE times emitter resistance 1 plus emitter resistance 2, 1.06 MA times 940 ohms. 940 is from adding RE1 and RE2, which is 470 plus 470 equals to 940. So 1.06 MA times 940, the value for VE is 1 volt. For base voltage, VE plus 0.7 volts, which VE is 1 volt, and 0.7 is the constant value of VBE. So the value for VB is 1.7 volts. For collector voltage, VCC minus IC times RC. So 10 volts minus 1.06 MA times 4.7k ohms, the value for VC is 5.02 volts. So here is the AC equivalent of the circuit. We will now solve for R sub E, which is 26 MV, a constant, over emitter current. So 26 MV over 1.06 MA, the value for R sub E is 24.5 ohms. So we are tasked to find the attenuation from source to base through source resistance, and getting the attenuation in the base circuit from a 600 ohm source. So we will use this equation, total input resistance, which is R1 parallel to R2 and parallel to base input resistance. And base input resistance is the beta in AC times R sub E plus emitter resistance 1. We're now going to solve for base input resistance is equals to beta in AC times R sub E plus emitter resistance 1, which is 175 times 24.5 ohms plus 470 ohms. Value for R and base is 86.5 kilo ohms. For the total input resistance, we have the resistors in parallel. So 47k ohms, 10k ohms, 86.5k ohms. So the value for total input resistance is 7.53 kilo ohms. Solve for the value of attenuation. So source voltage over base voltage, we have RS plus RN total over RN total. So 600 ohms plus 7.53 kilo ohms over 7.53 kilo ohms. So the value for attenuation is 1.08. In the AC equivalent circuit, we're given an equation of RC, which is RC times RL over RC plus RL. So before we can get the value of the amplifier voltage gain, we're going to solve first the value for the collector resistance, which is 4.7 k ohms times 47 k ohms over 4.7 k ohms plus 47 k ohms. So the value for RC is 4.27 k ohms. Since we already have the value for RC, which is needed to solve for the voltage gain, so since the formula for AV is RC over RE1 or diameter resistance 1, 4.27 k ohms over 470 k ohms, the value for AV is 9.09. We'll now solve for overall voltage gain. So overall voltage gain is the reciprocal of the attenuation times the amplifier voltage gain. We have here overall voltage gain equals to 1 over 1.08 times 9.09, which is 8.45. We're going to determine the value of the output collector voltage, but we need to find first the value of the collector voltage. AC collector voltage is equals to source voltage, which have the value of 10 MV. So to solve for VC, overall voltage gain or times source voltage, which is 8.45 times 10 MV, the value for collector voltage is 84.5 MV. We're also going to determine the peak values. The maximum output collector voltage is equals to collector voltage in DC circuit plus 1.414, which is a constant, times collector voltage in AC circuit. So 5.02 volts plus 1.414 times 84.5 MV. The value for maximum output collector voltage is 5.14 volts. We're going to get the value for the minimum output collector voltage. We're going to subtract collector voltage in DC and the collector voltage in AC. So the value for the minimum output voltage is 4.90 volts. Since we already have the value for the collector voltage in AC, we can now solve for the output collector voltage. So output collector voltage is equals to 1.414 times collector voltage in AC. So 1.414 times 84.5 MV. The value for the output collector voltage is 119 MV.